Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. Your one stop for learning all the mathematics short tricks which are required to be smarter, develop a positive aptitude in mathematics, and to develop all those tendencies which help you in calculating 10 times faster and cracking all those competitive exams at professional level. So friends, this is the video on adding and subtracting the numbers 10x faster, and in this particular video I am going to take up adding and subtracting of irrational numbers. Now operations on irrational numbers, whenever the students see square root in the question, they feel little perturbed, and that is because the operations on the square roots, that is adding them, subtracting them, simplifying them, is a horror for so many students. So watch the complete video. You are going to learn something really useful which will form a base for higher calculations. The compilation of all these short tricks, over 350 short tricks is in our book Quant Aptitude, that is simplified for you, and 24 different chapters have been covered in the ebook itself, and you need to study all those chapters to feel comfortable with the simplification parts. So you can send me a message on WhatsApp 9896369963, that is the WhatsApp number. You can take a screenshot, or the description also contains all these details of my WhatsApp number. So friends, what is the concept of the trick? Understanding the concept is the first thing you have to do when you have to master any particular skill. So let's understand the concept used in the trick. It's not exactly a trick. You may call it a method, but there are some prerequisites. There are some things which I need to understand when we are dealing with square roots. The first thing is, whenever we have square root of a prime number, see, just like square root of 11, square root of 19, all these numbers, they cannot be simplified because they do not have further smaller prime factors. And that is why square root of a prime number, wherever that comes, you have to leave it as it is, because you can't do anything with that. And simultaneously, you may have square root of a composite number, but still it won't get factorized, or there will not be any use of factorization. Like suppose I say square root of 15. Now what do I do with making the factors of 15 as 3 into 5? I can't do anything with this also, because no factor forms a pair, and therefore root 15 also has to be left intact. But there are some numbers where factorization works because it simplifies our radical. Let's see square root of 12. Now unlike square root of 15, I have to factorize 12 here. Why? Because 12 is 2 times 2 times 3, and now 2 forms a pair, so it comes out of the radical sign and 3 remains inside the radical sign, giving me the simplified form of root 12 as 2 root 3. See, there is a difference between root 11, root 15 and root 12. All three have to be dealt with in a different manner. Root 11 left intact, root 15 check the factors, but if nothing forms a pair, leave it intact, and then root 12 check the factors. If something forms a pair, bring it out of the radical sign and simplify it. These are some of the very basic things in handling the square roots. One more very important thing. Now suppose you have something like root 8, okay, and we want to add 7 root say 28, okay. Now can they be added? We can't add them directly, right? But root 8 is root 2 times 2 times 2, and 7 times root 28 is 2 times 2 4, 4 times 7 28. Now I see some pairs of factors which I can bring out. So 2 comes out, this single 2 remains inside, here 2 comes out, and this is the important thing now. When the 2 comes out, there is already a number 7 which is multiplied by this radical. So 2 also gets multiplied by 7, makes it 14, and the 7 is a single factor, so remains inside. Now I can't do anything with this. Only the rational part, 2 and 14. I can actually take it 2 as a common factor, which leaves me with root 2 and 7 root 7 inside the bracket, and nothing can be done further. Now these are the simplification things, the concepts which you need to know if you want to understand what is going on in the video in the next slide. Let's see. Look at this question here. All are composite numbers, 64 to 56, 1024, 12, 75, they are all composite numbers. So I am going to go for factorization. Now, if you know directly that square root of 64 actually is 8, or you know that 64 is 8 times 8, I don't need to write 8 as 2 times 2 times 2. Now, similarly here, if I know 256 is 16 into 16, it works because 16 will form a pair and come out. Likewise, 1024, if you know that this is 32 into 32. Now, this works because this is 8, this is 16, and this is 32, and I'll have my final answer 24 minus 32, which is negative 8. All these numbers were perfect squares, and that is why I could do it so easily. But if you don't know the square root of 256 or the square root of 1024, you have to break 1024 into smaller factors. I broke it down as 32 into 32. You might have to write 2 times 2 times 2 times 2, 10 times 2. That is the actual factorization of 1024. So as per your comfort level, as per your mastery of this skill, you can skip the steps. Likewise, if you see this question, here this 3 inside the radical sign is a prime number. So I can't do anything with that. So 4 root 3 remains as such, but this 3 and the 12 here, I can actually factorize it as 2 times 3, and then 2 root 75 as this is 25 into 3, right? So 5 into 5 into 3. Now I can see some pairs. So 4 root 3 minus the 2 comes out and gets multiplied by 3. 3 2s are 6. And the 3 remains inside, plus this is 2, so I don't want to write 2. I will directly write 5 into 2, 10, and then the 3 remains inside. So in all of these, you see the root 3, so you can take it as a common factor. So 4 minus 6 plus 10, which gives me minus 2 plus 10 root 3, and the answer is 8 root 3. See how we can subtract these irrational numbers using this concept which I told you in the previous slide. Let's practice some more questions now. Let's quickly do it now because I don't see any need of breaking the 10, because 2 times 5 is 10, it doesn't form a pair, so root 10 remains as such. Root 20 is square root of 4 into 5. There's a reason why I am doing that. This is square root of 4 into 10, 40. Square root of 5, I can't do anything with that, and square root of 80 is 16 into 5. See, this is what is smartness. I'm not breaking them down into smaller factors because I know that square root of 4 is 2. Square root of 4 is 2 and square root of 16 is 4. So root 10 plus, this is 2 and 5 remains inside, plus 2, 10 remains inside, minus root 5, no change. And then 4 comes out, root 5. So how many terms contain 10 here? Root 10, 1, 2. So 1 root 10 plus 2 root 10 is 3 root 10, and 2 root 5 minus root 5 is 1 root 5, and then minus 4 root 5 is minus 3 root 5. And there's one more step I can do. I can take 3 as a common factor, and root 10 minus root 5 remains inside the bracket, giving me the simplified answer for this particular question. Let's run through now. This is 12 times square root of 9 into 2, 18, minus 6 times 20 is 4 into 5, minus 3 times 50 is 25 into 2, and then plus 8 times square root of 9 into 5. So 9 is 3, right? So 3 comes out, gets multiplied by 12, 36 root 2, minus 2 comes out, gets multiplied by 6, 12 root 5 minus 5 comes out, 5 3s are 15 root 2, and finally 3 comes out, 8 3s are 24 root 5. Now let's combine the like terms. This one and this one, they both contain root 2. So this is 36 minus 15 times root 2. And this term and this term, they both contain root 5. So this is 24 minus 12 with a root 5. And so I have my answer. This is 21 root 2 and this is 12 root 5. Although you can take a 3 common, and then you will have 7 root 2 plus 4 root 5 as the answer for the question. Doesn't it work so nicely, friends? Let's have one more question in which we have a root 6 in the denominator. So root 216 is 36 into 6. 5 root 6, I can't do anything with this. This is square root of, I think 294 is divisible by 49. How about doing 49 into 6? 9 6 are 54, so 24, 29. Yeah, exactly 49 into 6. So 49 into 6. And this 3 upon root 6, what do I do with this? I'll just rationalize it by root 6, like this. So 3 root 6 in the numerator, this and this, and root 6 into root 6 is 6. So this actually becomes root 6 upon 2. So I will write minus root 6 upon 2. So 36 comes out and becomes 6. This 6 remains inside, minus 5 root 6 plus 49 comes out 7, and the 6 remains inside, minus half and root 6. So we have a root 6 in everything. So we will write 6 minus 5 plus 7 minus half followed by a root 6. This gives me 6 minus 5, 1, 1 plus 7, 8. 8 minus half. Now 8 minus half is 16 minus 1, 15 by 2. So your answer for the question is 15 by 2 root 6, which is the simplified version of the answer. So friends, these are the things you need to understand in these very important concepts of irrational numbers, how to apply the operations and get to our final answer for the question easily. So friends, if you're liking all these videos given in this chapter, do subscribe to our YouTube channel, Suresh Aggarwal's Mathematics Shortcuts, and do not forget to hit the bell icon. Now this is really important. Otherwise, you will not be getting the notifications. So if you want to get all the notifications on your mobile, subscribe and then click the bell shaped icon. Do put in a lot of hours on practicing irrational numbers, because this is a very important part of mathematics of future classes. So friends, I hope you like this video. Do give it a share and all the best for your practice.